Hey everyone, if we haven't already met, I'm Alex Hoffman, and today we're going to be talking about asset libraries. But after asset libraries, we're going to be talking about how to write better tests using TDD. A little bit about me. I am the JavaScript specialty lead here at Excella. I'm a JavaScript and Angular enthusiast, certified Scrum Master, and certified Scrum developer. I'm also one of the fabulous organizers of Angular DC. Some things I enjoy are sports, good food, and losing at bar trivia on a weekly basis. If you want to contact me, my email address is alexhoffman617@gmail.com, and my GitHub is conveniently also alexhoffman617. So branding. So why test your code? To address anyone here who's writing code without testing it, why? You need to be testing your code. There's a million reasons why. There's really no excuse not to test it. Some benefits are that it prevents you from breaking your code. More importantly, it prevents other people who don't know as much as you from breaking your code. It lets you know when your code was accidentally broken, and it prevents you from deploying broken code to production and the stress-related headaches, acne, and general sadness that can cause. So what is TDD? TDD stands for test-driven development. Simply put, that's writing tests to drive development in small feedback cycles. TDD was defined by Rob Martin, the author of the Agile Manifesto, using 3 rules. The first one being you are not allowed to write any production code unless it is to make a failing unit test pass. The second one being you are not allowed to write any more of a unit test than is sufficient to fail. And third, you are not allowed to write any more production code than is sufficient to pass the one failing unit test that you have. This kind of describes what is often called a red-green refactor. Simply put, this is you write a test, it's failing, it's red. You write enough code to make it pass, it's green, rinse and repeat. Another failing test, red, make it pass, green, over and over again until your code is perfect and you're a happy developer. Let's do a quick example of that. Let's say we have a function, number plus 1, which is going to take a number and output that number plus 1. Our first test that we might write is given an input of 3, return 4. So to write code to pass this test, I'm going to put in return 4. If I have a test that says input 3, return 4, I'm going to get an output of 4, so that passes. Then I'm going to go back and say, well, I don't meet all my requirements, so let me write another test. It might be given an input of 10, return 11. So I'm going to have to go back and refactor my code, and now it's going to give me the input plus 1. At that point, I'd go back to my tests and say, hey, is there any other tests I can write that will meet the requirements but cause my code to fail? And the answer is no. So I know my code is perfect. Let's go to the opposite side now. We're going to look at what happens when you don't do TDD and when you write tests to code that already exists. Let's say we have a function. Looking at this function, we can say we're taking the input mod 2 and we're checking whether it equals 0. So what I'm seeing is this function is going to return true when you have an even number and false when you have an odd number. So if I'm going to write tests for that, it's going to look like this. There's going to be one that says if it should return true if the input is even. Maybe that's a for in, expect a true out. And a input is odd, then return false. Maybe if input of 3 and expect a return of false. So now let's look at what our requirements actually were for this code. So our requirements were to take any number input and output true if it's Tuesday and output false if it's not Tuesday. So not only now does our code not do what it was supposed to do, but also now we have tests verifying our bad code. When you write tests to code, you'll cover your code and you won't cover the requirements, which is, at the end of the day, requirements is what you want to hit. You want your code to do what you thought it needed to do. Also, you want, basically where we're getting at here is, this is a little bit of an obtuse example. Is something exactly like this going to happen on your project or where you're working with? No, it's not, but it's a little bit closer to what could happen than we'd like to believe as developers. You could be on a project, you write a piece of code, you don't test it. 3 months go by. Someone else comes in and appropriates your code for their own stuff. 2 more months go by. You come back in and you're like, oh, I'm gonna write some tests for this. It's been 5 months now. You don't know why this code is here. You just know that it's not tested. You're gonna go in and you're gonna write tests to the code, and you're gonna end up with what we had here, where your code is wrong and now you've written tests to confirm that your wrong code actually is right. So that's a problem. Tests, ideally, you shouldn't have to change your tests when you change your code. Instead, your tests should verify that when your code changes, it's still working. So why do we TDD? Let's list a few reasons. Biggest one, and the one I've been hammering home, is you want your code to follow your requirements. You want your code to do what it's supposed to do. Some other benefits, though, are that it's going to prevent unnecessary code or complications. A lot of us have seen code that doesn't do anything. You've got a for loop, and whatever happens in the for loop doesn't matter. It doesn't need to be there. Dead code, or code that's unnecessarily complicated. Developing it with the TDD method will generally and hypothetically cut all of that out of your code. It's also going to help you think on a more granular level. Because you're doing it one small piece at a time, you're going to be able to focus on small pieces more granular. Also, by coding in that method, it's going to be more readable because it's going to be thought by thought as opposed to hitting 10 things all at once. So let's look at a real world example that I came across recently. On recent client, we had a requirement to have a function that did a date gap analysis. Basically, we were getting a start date, an end date, and an array of date gaps, which were date ranges. We had to return every gap between the start date and the end date that wasn't covered somewhere in all of our date ranges. Another requirement that was on there that I'd like to point out for what we'll figure out and I'll point back to in a second is that one day could be a date gap. So if you had a date range that ended on 3/3/2020 and one that started on 3/5/2020, that would create a date gap from 3/4/2020 to 3/4/2020. So I did TDD with this problem, and here is the list of tests that I came up with. And we're not looking at real tests because this is a shorter talk and we don't have time, but we're just going to look at the test names and assume I wrote the test properly. So there are a lot of tests here, which is good. It means I hit a lot of requirements and I hit a lot of edge cases that maybe I wouldn't have thought of, but I want to point out a few tests specifically. The first one is returns an array where there are no date gaps. This is pretty simple. It's the baseline case of what should happen. And often when you're writing tests to your code, you're going to forget this. You're going to say, oh, the basic stuff works. I don't need to test it, which is great until this basic stuff doesn't work anymore and you don't know why your code isn't working. Second thing I'd like to point out is properly finds a gap when there is a one-day gap. That points directly back to the requirement that I pointed out. We actually have tests that line up to requirements, which is great if, for example, you have a client that you have to prove that you're doing a good job doing what you're doing, and it's just comforting to see that, to be able to look back and say, hey, I know that my code is doing what it's supposed to be doing because of that match. And finally, I'd like to look at two last tests: properly finds a gap in a leap year and properly handles when the date ranges are not in order. So these are two tests I can guarantee that I would not have written if I was writing to my code as opposed to writing to TDD. TDD, basically what you're doing is you're purposely trying to break your code. You're looking at your requirements and what can go wrong and saying, hey, are there any tests I can put in that will cause a breakage? When you've written a full piece of code without testing and then you're going into testing, we all are perfect developers and we'd like to think that all of our code is perfect, and we really don't want to break our own code. So there's a mental hurdle you have to get over in order to find these small edge cases that are going to break your code. But when you're using TD, your goal is to break your code. There's a positive correlation with, hey, what I'm supposed to be doing is finding the next breakage, which kind of makes it easier to write these tests. We're trying to, as opposed to, oh man, I'm upset that I have to, which makes us more likely to write them and more likely to catch these weird edge cases. So let's get realistic for a second. Not everyone's going to be in a situation where you can write TDD all the time. Everyone's been doing something where they have pressure from a client or a supervisor or from someone else on their team, or a self-set deadline where you need code out and you needed it out yesterday. TDD does take more time than just throwing code out there, plain and simple. And sometimes you're just not going to be able to do it. Also, if you're working on a team in some sort of team structure, you're not necessarily going to get buy-in from everyone on your team, whether they don't believe in the TDD methodology or whether they just don't like to do it. They don't like the time that it takes. Maybe they don't believe in it as much as I do, for instance. For those situations, I would say do it when you can. Even using it part of the time can be very beneficial both to your code base and to your development as a developer. Identify scenarios where it would be good to use TDD. An easy one being anything that has to do with date math. Date math is hard, date math is stupid, date math doesn't make sense a lot of the times. You use TDD, you're going to hit the edge cases there. If you have really complex functions, that's another place where using TDD could help you break it down into pieces. That can be helpful. Also, if you have long code. Long code, when you're writing a huge piece of code, you can get into it, all of a sudden your variables, instead of being named properly, are I and X and letters that don't make sense anymore. If you're doing it in TDD, your thoughts will be broken down into small pieces, and when the next developer comes through to read it, or when you're coming back to look at it 2 months down the line, you're going to be able to understand it better. So TBFA, too boring, fell asleep. If anyone's fallen asleep and wants a quick summary of what we just went over, test-driven development is the practice of writing tests based on the requirements before writing code. Red, green, refactor, that's what we talked about. Using TDD properly ensures that your code matches what is needed as opposed to writing tests to code which can result in lost requirements. At the end of the day, we want our code to do what we think our code is supposed to do. Writing tests before coding can make it easier to identify edge cases. Hello leap year, hello something that I haven't thought about yet. Good example, just looking at those tests, I didn't think about what happens when date times are different. I was just looking at straight up dates. Edge cases, that's something you can pick up. Using TDD will ensure that you have a robust test suite, even if you're a magical unicorn developer and you're going to write your code perfectly the first time, just the same as you would have if you wrote TDD. If you're using TDD, at least you have all your tests done at the very end. So you've saved yourself some time and thought instead of having to go back and do the boring work of, hey, I'm going to write tests for code that's already working. And finally, using TDD can help improve your code readability. If you're working on any sort of team, or even if you're not, you don't know who's going to be touching your code in the future. And let's be good to the community and try and make it so that they can understand the brilliant things that we're all coming up with.